These are our solutions to the exercises we've created based on the article we chose. Let's get started. Our first question reads the following. Let's suppose that Hannah earns 15 euros an hour for a 40-hour week, and her disutility of effort is 3 euros an hour. Compute Hannah's employment rent and her net utility per hour. Explain the results. To compute the net utility per hour, we must subtract to Hannah's wage her disutility of effort, that is, 15 minus 3, which is equal to 12 euros per hour. When it comes to the employment rent per hour, we must subtract to Hannah's wage not only her disutility of effort, but also her reservation wage. That is equal to 15 minus 3, which is also 12. Because the reservation wage in this case is 0, the net utility is equal to the employment rent.
Now, let's assume that, as seen in the article, the macroeconomic situation results in an increase in Hannah's reservation option to 10 euros, and an increase in her disutility of effort to 5 euros, due to concerns regarding the pandemic. Given this new scenario, compute Hannah's employment rent per hour. Now, her employment rent is equal to her wage minus her reservation wage and her disutility of effort. That is, 15 minus 10 minus 5, which is equal to 0. Will she want to continue to work in this situation? Explain your answer. Given the fact that her employment rent is 0, she won't want to continue to work in this situation, because her disutility of effort and her reservation option increased to a point in which her salary doesn't benefit her in comparison to leaving the job.
This time, Anna can choose the amount of effort she exerts into her work, depending on her employment rent. This will be represented by her best response curve, E equals 1 over 20 times the square root of W minus 3. Knowing this, Roger, Hannah's employer, will choose her salary accordingly. Determine the salary Roger will give to Anna and the amount of effort she will exert given that salary. In this exercise, we have to find the slope of the best response function and match it with E over W, the isocost line general function. This gives us that E is equal to W over 40 times the square root of W minus 3. Then, we replace this value in the best response function so that we can determine the wage Roger will give to Anna, which is 6. To discover the amount of effort she will exert receiving this wage, we have to replace in the best response function W with 6, getting approximately 0.09 effort.
Now let's consider once again the increase in Anna's reservation option to 10 euros and the increase in her disutility of work to 5 euros, giving her new best response curve has effort is equal to 1 over 20 times square root of the wage minus 15. What do you think will happen to Anna's wage if her employer wants to maximize his payoff? Will her wage increase or decrease? For the employer to maximize his profit, Anna's wage will have to increase, since her best response curve will deviate to the right, meaning that for her to exert the same amount of effort, she will require a higher pay.
Now, compute their payoff and confirm your answer from the previous question. In this exercise, which is very similar to D, we have to find the slope of the best response function and match it with effort divided by wage as well. In this case, this gives us that effort is equal to wage over 40 times the square root of wage minus 15. Then, we replace this value in the best response function so that we can determine the wage Roger will now give to Hannah according to her new best response function, which is 30. To discover the amount of effort she will exert receiving this new wage, we have to replace in the best response function wage by 30, getting approximately 0.19 of effort. Considering this result, our prediction is proven to be correct, since the optimal point in D was 6 euros of wage and 0.09 of effort, and now the optimal point we reach is 30 euros of wage and 0.19 of effort.